Think of how well-traveled and eco-responsible you would be if you could economically zip between cities at speeds exceeding 700 miles per hour in a comfortable carbon-neutral way, without going to the airport. We live in an age of unbelievable technological progress. Dreams never die, however, and the fantasy of futuristic transportation is very much alive right now, as exemplified by a concept called the Hyperloop. First proposed by Elon Musk, the theoretical transportation system we call Hyperloop would propel people or cargo-filled pods over long distances through steel tubes. Hyperloop is a new form of ground transport currently in development by a number of companies. It could see passengers traveling at over 700 miles an hour in floating pod which races along inside giant low-pressure tubes, either above or below ground. Why the need? Conventional means of transportation tend to be some mix of expensive, slow, and environmentally harmful. Road travel is particularly problematic, given carbon emissions and the fluctuating price of oil. As the environmental dangers of energy consumption continue to worsen, mass transit will be crucial in the years to come. What makes Hyperloop different? There are two big differences between Hyperloop and traditional rail. Firstly, the pods carrying passengers travel through tubes or tunnels from which most of the air has been removed to reduce friction. This should allow the pods to travel at up to 750 miles per hour. Secondly, rather than using wheels like a train or car, the pods are designed to float on air skis, using the same basic idea as an air hockey table, or use magnetic levitation to reduce friction. How do Hyperloop capsules work? At its core, Hyperloop is all about removing the two things that slow down regular vehicles, friction and air resistance. To do away with the former, you make the pod hover above its track, like a magnetic levitation train. The Hyperloop capsules in Musk's model float above the tube's surface on a set of 28 air-bearing skis, similar to the way that the puck floats just above the table on an air hockey game. One major difference is that it is the pod that generates the air cushion, not the track. Other versions of Hyperloop use magnetic levitation rather than air to keep the passenger pods above the tracks. As for air resistance, that's where the tube comes in. The basic idea of Hyperloop as envisioned by Musk is that the passenger pods or capsules travel through a tube. The tubes enclose the space through which the pods move, so to reduce friction, most, but not all, of the air is removed from the tubes by pumps that way of vacuums is created, leaving so little air that the physics are like being at an altitude of 200,000 feet. How would Hyperloop be powered? The pods will get their velocity from an external linear electric motor, effectively a round induction motor like the one in the Tesla Model S, rolled flat. Under Musk's model, the Hyperloop would be powered by solar panels placed on the top of the tube, which would allow the system to generate more energy than it needs to run. The pod would get its initial velocity from an external electric motor, which would accelerate it to high subsonic velocity and then give it a boost every 70 miles or so. In between, the pod would coast along in near vacuum. Each capsule could carry 28 passengers, other versions aim to carry up to 40, plus some luggage. Another version of the pods could carry cargo and vehicles. Pods would depart every 2 minutes, or every 30 seconds at peak usage. The future of Hyperloop. There are lots of renderings and promises out there. The companies in this space have announced plans to build Hyperloops in California, Colorado, on the East Coast, in India, Slovenia, Dubai, and Abu Dhabi. Hyperloop 1 wants a commercial line in service in 2020. Over the next few years, then, we'll start to see answers to the real question here. It's not can Hyperloop work? We know the engineering makes sense. As Bam Brogan puts it, it's within the laws of physics, but hard enough to be fun.